Hi, my name is Jay Beale. I'm going to talk to you about hacking Kubernetes, and I'm going to do it by way of showing you the DEF CON Kubernetes capture the flag attack path. Real quick, I've got a graphical bio, things I care about or work on, including my Black Hat class and my company and Guardians. So I'm going to talk about the DEF CON Kubernetes capture the flag. Quick shout out first to the winners, El Tigre, Poop Poop Gang Gang, Alpha Chains, and Cuckoo's Bizarre Adventure, and also to the staff that helped build and run the DEF CON Kubernetes CTF. So with that, the bulk of this talk is all demo. Our capture the flag at DEF CON was themed on the Hackers movie. So if you haven't seen it, pause the talk right now, go watch the movie. I'll wait here. Okay, cool. I hope you really enjoyed it. Let's get straight into our demo. So we started out, we gave each of the teams an IP address for one node of their Kubernetes cluster and nothing else. So they port scanned and they found that there was a web server on this port, 30,080, and they did a dictionary attack to find there was an API endpoint called, /vent. And when they communicate with /vent, it comes back and says, hey, this requires a parameter of command. We're just trying to get them in the cluster at this point. So so they try passing a parameter for command ID. It says they get back a helpful error. Hey, that's got to be base 64 encoded. Okay, simple enough. Let's create a little variable called command, and we'll make it so it actually goes into the URL is always base 64 encoded, just to make things a little easy. So we find out we've got a root shell in something. This is exactly what I want. We want RCE. By the way, you'll notice the prompt here, we're playing Zero Cool from the movie. So now we're going to take that command and we're going to just set up a quick, we're going to have the container that we're hitting here pull a copy of our sliver binary. It's a C2 tool from a web server. Make it executable and run it. And that gets us into Sliver. So now I'm going to go and use that session. And we're now in this, on this, seemingly host. It's actually a pod. It's a container in a Kubernetes pod called Joey. Joey was that character in the movie that had the floppy disk that he hid in his vent. So we've got our first, says we got your first flag. The way you're going to get that, see that flag is by requesting the secret in the Joey's vent namespace, because that's where he put his floppy disk, and the secrets has floppy in it. So, and then after that, it says we should try to find a Redis server without port scanning, and then we'll exploit that to get our next flag. So first, let's real quick just go grab that floppy disk with a single kube control command. We've already set things, we've put kube control binaries in all the pods, just try to make things a little bit easier on the players. So you go and ask for that secret, go and say that you'd like to have it kicked out in JSON and use JQ. We didn't have JQ on here, so the player and Zero Cool is going to add that. Just something that makes it really easy to parse out JSON. And so we'll say, hey, give me the data. Okay, give me the flag. Okay, now just base 64 decode it. And here we go. We've got the flag. We see Joey with his hands up. Let's look at that hint one more time. It says, see if you can find a Redis server without port scanning. I'm going to find it without port scanning. Now, Redis had this great vulnerability in it that we're going to be able to use, or it had this great exploit that's kind of very basic. But first, let's do an environment variable look. We see that when you're in a container in a Kubernetes cluster, there's some environment variables, including an IP address where you can find the API server that we're making requests against. We've been able to just do it really naturally, but there'll be times where we'll have to add that in. So we also see like the port that we came in on is a Kubernetes service, and we'll leave the rest of that alone. I'm going to clear the screen. And now the player had to find a service, had to find that Redis server without port scanning. There's a trick that you can use for DNS, but what we wanted to do is put it in the config map. And config map's used to basically push configuration data into pods so that they're not in the container images. And so the player would, the players would have to enumerate, and eventually they'd figure out, like, let's look for a config map. And there's a config map called scoring Gibsons, and we can ask for it. Again, we're using JQ to make that a little more readable. And we find, some cool quotes from the movie, and we find an IP address. We're looking for a Redis, a Redis IP address. This is going to be it. We found a port, and we also found this thing called an SSH IP. And the main, the well-publicized way of turning Redis access into command line access into RCE involves SSH. So that's clearly going to be helpful. There's some quotes from the movie, including, if you want to do a righteous hack, you got to go after one of the Gibsons, and that's where the plot for the capture the flag is going to go. So let's connect to that SSH IP on 22. We see, there's an SSH server, cool. And we put in Redis CLI here already. Let's put in that host and that port and just try ping. We get back a pong, and that means that we're connecting to Redis, and we don't have to authenticate. This is where, worms like Redis Wanamine got to exploit this after the Redis author made a post and said, listen, the whole idea of Redis security is just keep it behind a firewall. Here I'll show you how easy it is to turn Redis access into command line access. And his recipe is what we're using here. It's also what Worms used. So we create an SSH key, and we write that into a standard file, and then we add some spaces on either side, some blank lines, because what we're going to do is we're going to write that into the Redis database and then tell Redis to save its database in a different place. So what we do here is set up an alias. So we're going to say empty the database. Now write that file into a key called crackit. Now set the directory where the database will be kept as /root.ssh, set the file name where the database will be kept to be authorized keys, and then save. And as soon as we do that, we've written into root's SSH authorized key file. So let's go and SSH into that IP address, into that 1044.02. And here we are. Cool. So we've gotten to the next place, serial Redis. We can enumerate. The first thing we're going to do is just put a new sliver implant in here, just to keep making things really easy for us to move files in and out and have some persistence. So here we go. As soon as we run that sliver implant that we pulled down, we get another session in sliver. And we're using disown to leave that thing running even as we exit the shell. So let's go, and we've got a Joey session, but let's move into the serial session. So serial is named for the character serial killer in the movie. And let's look at the hint. So the hint says, okay, cool, get a new flag, get the serial flag serial, and then go check out the services in the Freak's 9x Kingdom namespace. So Freak was another character. It says this has a couple of tricky bits. So first, let's grab our flag, and we're going to need for that flag, we're going to need that IP address for the server. We don't have it here because of the way, because we've SSH'd in instead of going into the process that was the first one in the container. So we just jump back over to Joey, grab that 1096.01 from the environment variable, back all over into serials pod, and we set up an alias for kube control that uses the service account. And just like we did with Joey, we're using the service account that's automatically mounted into the pod by default. A great hardening step would be to make it so that those service accounts weren't automatically mounted unless they were needed. So we're going to now take that, set up kube control to use serial service account, and we'll go and grab serial's flag. And this time, no JQ. We're going to just do our own thing. So now we've got serial killer's flag with his "we are nameless" quote. So let's look at that hint one more time. It says, look at the services in the next namespace. So we're in serial's namespace. We're going to look at the services in Freak's 9x Kingdom namespace. And there are two of them. One's called Blade. One's called something really nice. What's the password RCE? I kind of like the sound of that. but let's go and get some of the details on those services. So we have a service object, and we're going to look at this again in a second with a little more detail, but we have a name for the service, Blade, an IP address the service creates. It's basically, a service is basically a Kubernetes load balancer. And we have ports. Anything going to port 80 on that service will go to port 8000, and it'll go to port 8000 on any pod in the namespace whose app label is set to Blade. That's going to come up again. So look at the other service, what's the password RCE, and same kind of thing. There's a port, there's a target port, there's that IP address, and this goes to anything where the app label is set to freak. Wow, it must be really hard to set those app labels. That must have some kind of authentication behind it or something, right? Not so much. That's what we're going to come to. So we try curling this service, the what's the password RCE, and it just hangs, so we can't reach it. And we can go try the same thing on the Blade service. So we try curling Blade service, also just hangs. So players have to figure out we had hints on their scoreboard, but eventually what they figure out is there's a network policy, kind of Kubernetes firewall rule set on the Freaks 9x Kingdom namespace, and it basically is a default deny. So what we can do is try a cool little trick, auth can I, kube control auth can I list, say what things am I allowed to do, and I see that for network policies, I'm allowed to list them, I'm allowed to delete them, I'm allowed to update them, create them. This is great. So as a player, what do? Well, just delete the one. So I'll delete that default deny all. And now when I try curling Blade service, boom, I can get to it. I find it's just this kind of simple form that says, hey, send me the service account token. And it's a form with a get method, which is kind of nice because that means it shows up in the output shows up in the form elements show up in logs. There's a flag and a token. Cool. Okay. Well, let's hit that. What's the password RCE? So we hit that. What's the password RCE? And it says, hey, I need two parameters, password and command. So let's try password equals secret. And if we watch the movie, there were they talked about the most commonly used passwords, which included the ones we'll try here. So secret. We try command and it says, hey, your password's not correct. So instead of secret, let's try love. That doesn't work. Let's try God. And in the movie, God was one of those. Secret, love, and God were three of the most commonly used passwords, and God was the one that was actually used, which was kind of fun. And now we'll try out commands, and we find out command has to be base 64 encoded, just like our first RCE, and so we can do that same thing where we try different commands in base 64 encoding. So we say, okay, that's root. So let's set up our command to be go grab a sliver. Go grab a sliver implant from this web server and run it, and we'll write out the temp. So we get a little issue, and it's easily cleared up by just adding an argument to the base 64 command. So at this point, we've got a new session coming in. And every now and then I had issues with Sliver, and just had to kill the server and restart it. So you get to see that here. So we restart it up, and the implants all connect right back in. So we're going to use what's now session number 1. What's the password RCE? Ask for a shell, and look at our new hint. And here it goes. It says, hey, go get your flag, Freak's payphone trick. Freak in the movie uses a playback, a cassette recorder to play back the sound of coins hitting in a payphone, and gets to use the payphone for free. I know what's a payphone, but anyway, it's an old movie. And it says, okay, there are multiple challenges, and they're not going to give you a new pod yet. So the first one is that Razor reaches Blade by way of a service and says, okay, and says, can you enter the token? But let's go grab our flag. and we've got Freak's flag, Freak's payphone trick. And now look at our hint one more time. It says multiple serial challenges. And challenge number 1 is Razor reaches Blade by way of a service. Can you intercept the messages? There's a flag and a service count token in these. And it says the service count token isn't Razor's token, it's not Blade's token. We're going to get one separate from that. The second challenge is once you have that, we want you to steal the DaVinci service count token in the Ellingson Mineral or Ellingson Min namespace. And that's going to let you claim the flag DaVinci secret in that namespace. And then the third challenge will be to connect to the Ellingson Mineral namespace's Gibson pod, get OCE in that pod. And that's basically going to get you all the way to the end. So let's get straight into the first challenge. So the cool thing, when we were looking at services earlier, we try to get services, and this service count token, the one that's in Freaks, that's in this Freak pod, isn't permitted to list services. So what we can do is switch back over and use a token that is. Now, if we'd written these tokens to a file, then we could just stay in the same pod and use that token from another, from another pod, because there isn't any kind of limitation that says you can only use this token from the existing pod. The tokens are these JWTs that just assert this is, it's a signed thing that asserts this, asserts an identity. So we'll go and say, give me a list of services, and we want that Blade service. And the Blade service says anything. So Razor's trying to contact Blade. Razor does it by talking to the Blade service. You can get, the cool thing is you can get anything that's intended for the Blade service. You can get a copy of, or you can be one of the recipients of the Blade service, and you just create a pod whose app label is set to Blade. So that's what we can do. So let's switch back over, and what we'll do is we'll take a look at what the Blade service does. The Blade service is just a web server with a GET request. So if we can stand up something that's going to be able to catch incoming requests, we'll be in great shape. So we created an image called web server share my logs. So players could do a number of different things like this. We created an image called share my logs. You just have to set your app label to Blade. And if you do that, this pod that you created, we've called it, we've called it monkey in the middle, MITM. If you use, if your pod, has that label, it will get some of the requests, not all. It'll get actually, kind of half of the requests that are going to that are supposed to go to Blade. So once we start this up, we've set this up. We've got the IP address, and this pod this container we created, all it's going to do is it's running a web server, and it makes its logs visible makes the web server logs visible it serves up its own logs. So we can take a look at the requests at its logs and see that we've got that flag, the Razor flag, and we've also got a service count token. So we can go and grab that flag. Hey, there's Razor and Blade holding up what must have been a modern laptop at the time. So let's take that token that we got and write it out to a file. So we call it token from Razor. And that token, we'll need to base64 decode it. And we've written it out the token now. And now we can use it in kube control and try to do something. So we just say get pods, kind of one of the things I like to do to just see if I've configured kube control correctly. And this says, hey, your service count, Ellingson Min, the plague, which is one of the bad guys in the film, isn't allowed to list pods in Freak's 9X Kingdom. But we could figure out what that token's able to do in Ellingson Minerals namespace. So we set this up. We're going to use that plague token. We say in Ellingson Mineral, let's get a list of pods. We see there's a pod called Gibson. I remember that's what we're supposed to go after. And plague is that guy on the right, sitting next to a very famous magician, Penn Teller. So that means we've gotten the first challenge. So now what we're supposed to do in the second challenge is steal the DaVinci service counts token. So how are we going to do that? How are we going to steal the token? tried RCE, but that's not going to be the thing we do here. What is going to be is if we take a look at what this service count is allowed to do, the plague is allowed to create pods. Well, that is sure helpful. So if we can create pods in the Ellingson mineral namespace, here's a cool thing. We can name any service count we want. There's no authorization on that. So we can just say, I'm going to create a pod. I'll name it get DaVinci service count. And I'll just say that its service account that should be, given to it is DaVinci. And as long as that's created, I now have access to the DaVinci to the DaVinci service count. So we set this one up to have used just a container image that has an intentional remote code execution vulnerability. So we're just going to use that vulnerability real quick. We used this. The player could use some other image. This is just the image we're using. It's not so much part of the contest, right? So we're able to run commands, and so once we can run commands, we can put our own, we can tell it, hey, I'd like to make my command that pull another, sliver implant and give me another sliver session. So we've done that. So now we're in that get DaVinci pod, and in the DaVinci pod, auto mounted straight in to var run secrets Kubernetes IO service count is a token. So now we've got that token, and that gets us through the second challenge. So we're just going to try to write that out to a file real quick. And just doing the magic copy and paste. And now we can, we're in here, we can use that token straight away, but we also have it written out to a file. So let's keep moving. We grab a flag. And we've got DaVinci blames hackers. Okay, so we've got one last challenge. Let's look at that. Let's look at that hint one more time. So our hint says connect to the Ellingson Minerals namespace's Gibson pod and get RCE. So let's get an IP address for that pod with kube control, and now let's reach out to it. And we get row, unless $5 million are transferred the following numbered account in 7 days, I will capsize 5 tankers in the Ellingson fleet. And then it says that this PHP page's next line of code is an include statement for an external server. And there's this really cool CVE 2020-8554 in Kubernetes. This is just, it turns out to be a works as intended kind of vulnerability. And what it is if we, it's called an active, we can create a service, and we can say any traffic that's leaving the cluster going to this external IP address should instead go to pods that we define. So we're going to find out what the IP address is for static, for that, for the website that this container is going and pulling PHP code from. And we can go and create our own service and create a pod to catch it. So we created a pod first called SSI for serve static inclusion, and it's going to serve. It's got a label of app hack the planet. So the service we create has to have the same label, and it's just going to use a container we've created, and that container is going to serve up serve up our own PHP file. So let's go back over, and we're also uploading our CVE file. And this is the payload for the hack. This is what that CVE lets us do. Is if we can create a service, then anyone who can create a service is going to be able to make it so that the things that are for this external IP instead go to pods with the label app hack the planet, and basically say what port maps to what port. So let's go and apply that pod. So we were allowed to create a service that was something that the DaVinci service account token could do. And now this is running. We've got the pod running, and hopefully when we hit that pod, and I should back up. I should say that when the way that worked, I'm just going to back up slightly. Once we set that up, when we curled the target, when we curled Gibson then got made a request to that external IP. It got redirected to our SSI pod. Our SSI pod served up PHP and got us code execution. So we now have a session inside of Gibson, and that's the end of the end of the line. So quickly, we're gonna go and grab the secrets, go and grab the service count token out of this. We'll write it out to a file, and we'll use it to go and get the secret, the flag that corresponds to Gibson. And this is named in the hints file way to tell them about this. So we're gonna download that Gibson token, go back over to that to our what's the password RCE and upload it there. And we'll run our kubectl get pods and our kubectl token set to that Gibson token file and get the flag Gibson flag. Hey. Oh, right. Yeah. So the first try I set it up, missing a command. So we're going to take this now, and we've got our flag. We can base64 decode this flag and turn it in for our prize. And that's it. Gibson has weak passwords, like we're seeing in the movie. So I'm going to switch us back over to PowerPoint now. That was our demo. And I wanted to just map some of what we did over to the Mitre Att&ack Framework. So you saw that we moved through a number of these stages. We exploited a public-facing application and finding that Joey's vent. And I'd say that's a little bit more like an external remote service. And at that point, we got a service count token. That's and that's our credential access. As soon as we landed in, we got execution inside of our container. And once we had that, we got a service count token for Joey, and we just transparently used it. But you saw as we went through, we kept using service accounts, these JWTs that were mounted in automatically throughout the cluster. We did quite a bit of persistence in terms of just setting up our implants. In terms of privilege escalation, there were a number of places where we were clearly doing privilege escalation and moving laterally. I think that was quite fun. The other kind of big things we did here were in discovery. You saw us using kubectl a ton, and that's just that container resource discovery. We didn't do any network scanning. We didn't really have to, but we could have. I think otherwise you saw us in terms of evading defenses under impaired defenses. That would be us removing the firewall rules. And I think that's a good quick map. We're running low on time, so I just wanted to say we've got a couple things. We have a tool called Mitre that we make in Guardians, and it's a pen test tool for Kubernetes. And some of the things we do in these in our capture the flags are right there. Also, take a look at Bustakube, a cluster we make to defeat attacks like this. And then finally, come look us up at InGuardians. So cool. Thank you very much. I hope you enjoy the rest of the conference, and I hope you look me up and say hi. Thanks a lot.